Hello, my name is Shantanu Sarkar. Today I will discuss about the Minimax algorithm in artificial intelligence. Before explaining the example, I will give you an overview of the algorithm. First point is backtracking algorithm. It means it uses backtracking algorithm to find an optimal solution. In this, a candidate incrementally build towards a solution one step at a time, and the candidate that fails to complete a solution is immediately abandoned. And the next point is best move strategy. It means whatever moves are available in front of us, we will choose the best move. And then it says max will try to maximize its utility and min will try to minimize its utility. It means if there are two players, one will try to maximize his utility and minimize his opponent's utility. The opponent will also try the same thing. Let's take an example. By this we can understand this algorithm. Here is an example. Here these are the terminal values and these are the terminal nodes. These are the terminal nodes and these are the terminal values assigned to that terminal nodes. Here in step 1 we will set minus infinity in the maximizer and compare it with the terminal values, and we will assign the maximum value between them. Here you can see I assigned minus infinity to the maximizer and I have compared with the terminal nodes. Here minus infinity and minus 1. The maximum is minus 1, so I replaced it with minus 1, and again I compared it with 4. The maximum between them is 4, so I again replaced it with 4. Then same step I followed. Here I assigned minus infinity before and compared it with 2. So the maximum between minus infinity and 2 is 2, and again I have compared with 6 and the maximum between 2 and 6 is 6, so I have replaced it with 6. Here again I have followed the same steps and got the result. This is step 1. Now we are moving to the step 2. Let's see what is step 2. In step 2 we will set plus infinity to the minimizer and compare it with the maximizer values and choose the minimum value. Okay, these two are the maximizer and I have assigned plus infinity initially, plus infinity and plus infinity here, and compared it with the maximizer. Here between plus infinity and 4 the minimum value is 4, so I have assigned 4 here, and again between 4 and 6 the minimum value is 4, so the value is not changed here. And here previously I have assigned plus infinity and I am comparing it with the maximizer. So between plus infinity and minus 3 the minimum value is minus 3, so I am replacing it with minus 3, and between 7 and minus 3 the minimum value is minus 3, so I have not changed it. So we are moving to the step 3. This is the last and final step. In step 3, we will compare with the minimizer values and choose the greatest value. Okay, here these are two minimizers. So I have assigned in this maximizer minus infinity and comparing with the minimizer. Here between minus infinity and plus 4, the maximum value is 4. So I have replaced it with 4. And between 4 and minus 3, the maximum value is 4. So it is not changed. So the ultimate answer is 4. That's all. This is an example. I hope you can understand it. And there are some disadvantages of this algorithm, like big branching factor. For this big branching factor causes slow for complex games. The main drawback of the Minimax algorithm is that it gets really slow for complex games such as chess. This type of games has a huge branching factor and the player has lots of choices to decide. This limitation of Minimax algorithm can be improved from alpha beta pruning. Okay, thank you for watching this video.